Hello everyone, my student number is 10502831. I'll be speaking about TCP, which is my second recording in this series. So TCP is Transmission Control Protocol, and it is a connection-oriented communication service between hosts in a network, and it's designed for reliable transfer of information. And it works in the transport layer and ensures reliability by establishing a connection, segmenting large chunks of data, and ensuring flow control with acknowledgements. Uh, on the TCP data unit is called a segment. The name is due to the fact that TCP does not recognize messages per se, but merely sends a block of bytes from the byte stream between the sender and the receiver. Now, in this image, you can see what a TCP segment format looks like. You can see the source port, a destination port, a sequence number, an acknowledgement number, data offset, reserved, a window, a checksum, an agent pointer, and options and data. Perhaps maybe we can look at some of these things and some of the segments inside there and just to explain what they are. So the source port and destination port identify the source and destination ports to identify the end-to-end connection and higher layer application. The sequence number contains the segment's first data byte in the overall connection byte stream. Since the sequence numbers refer to a byte count rather than a segment count, sequence numbers in contiguous TCP segments are not numbered sequentially. So you'll not find that when the data comes in that they have been numbered by when they came. They can all be mixed up and they are all put back together. And an acknowledgement number is used by the sender to acknowledge receipt of the data. This field indicates the sequence number of the next byte expected by the receiver. The data offset points to the first data byte in this segment. This field then indicates the segment header length. Then the control flags. There is a set of flags that control certain aspects of the TCP virtual connection, and they include the URG, the ACK, which is also known as the ARC, the PSH, the RSCT, the SYN, and the FIN. Then the window, it is used for flow control and contains the value of the received window size, which is the number of transmitted bytes that the sender of this segment is willing to accept from the receiver. And the checksum, which provides a bit error detection for the TCP segment. The checksum field covers the TCP segment header and data, as well as a 96-bit pseudo header that contains the IB header, source address, destination address, and the protocol fields, as well as the TCP segment length. And we have the agent pointer, where agent data is information that has been marked as high priority by a higher level application. And this data in turn usually bypasses normal TCP buffering and is placed in a segment between the header and normal data. Now the agent pointer is valid when the URG flag is set and indicates the position of the first octet of the non-expedited data in the segment. The last one, we have the options, and it's used at the connection establishment to negotiate a variety of options. That is a maximum segment size (MSS), and is the most commonly used option. And if it's absent, defaults to an MSS of 536. Another option is a selective acknowledgement, that is a SAC, which allows out-of-sequence segments to be accepted by a receiver. And the ARNA maintains a list of all TCP option numbers. Now, we've talked about the TCP handshake. So this is the method by which TCP creates a connection. So a TCP session begins when a client sends a TCP synchronization, that is a SYN segment, to the destination device, usually a server, and a destination port number, typically a well-known port such as port 53 or 80, and is specified, and a source port number is assigned dynamically. Now, when the server receives the SYN segment, it usually responds by sending one of two segments: an acknowledgement synchronization, that is an ACK SYN, on this axine segment, or a reset connection, that is the RSCT segment. Now, if an RSCT segment is returned, the server refused the request to open a session, possibly because the destination port is unknown. Now, and if an axine segment is returned, the client completes the three-way handshake by sending an ARC segment back to the server. Then at this point, the client is then ready to begin sending or requesting data. Now, TCP also segments data. How does it do so? Now, when TCP receives data from the application layer, the server of the data might be too large to send to the internetwork layer in one piece. And remember that Ethernet can only send frames that are only a maximum of 1518 bytes. Now, TCP breaks the data into smaller segments before handing each segment to the internetwork layer. Each segment is labeled with a sequence number so that if segments arrive at the destination out of order, they can be reassembled in the correct order by using a sequence number. TCP also ensures flow control with acknowledgements. How does it do so? Now, it provides flow control which prevents a destination from becoming overwhelmed by data resulting in dropped packets. It does this by establishing a maximum number of bytes called the window size, and that can be sent before the destination must acknowledge receipt of the data. Now, if a sending machine hasn't received an acknowledgement before sending the data, sending the number of bytes established by the window size, it stops sending the data. And if no acknowledgement is received in a specified timeout period, the sender transmits the data from the point at which an acknowledgement was last received. Now we can show how TCP is captured in Warshak. So we're going to open Warshak, view Warshak. Just start waiting. We're just going to wait for, see, there's activity on the Wi-Fi. So just wait for it. Yeah, it started capturing. So the IP address of this computer that I'm using currently, CMD, so we just want to make sure that we've filtered. So IP config. Our IP address is 10.65.47.190. And now using that IP address, we can actually filter out and see what how our computer is communicated on this network. So we're just going to open our browser this time and search for google.com. It's searched. I'm just going to exit the browser. I'm going to stop this capture and we're going to apply display filter of TCP. Using this, we can just try and get some of the few TCP basics that we've already seen from the TCP segments. And our IP address is already captured here as one of the first things. 10.65.47.19 communicating to the destination here. Those already see some ports here. Just for the TCP protocol, the source port at 647. There's a destination port 443. There's a sequence. There's one. There's an ARC 1 and LAN 1. So this TCP segment of a reassembled PDU. So this means that there is a continuation. That means this is a continuation. This is data. This is one part of data that has been captured. And you can see that there's communication from destination at this point at 52.113.194.131 back to our IP address using the same thing. I'm just going to highlight that, and you'll see now that the source port is 443 to destination port 64647, and the sequence number is 1. Acknowledgement number is now 2, which is very different from the first one that we had that was at 1. You can look at checksum. There's a window size scaling factor, is unknown at this point. There's a checksum. The status is unverified at this point. These are the flags that we mentioned. At this point, it's arc. There's the options, it's 12 bytes, on the SAC as well, the sequence and acknowledgement analysis. Just drop that down. This is an arc to the segment in frame 1. Just going down below, we can analyze all the TCP basics that we've done. It's the same IP address. Our IP address is working on this one. So another sequence here. Communication was client hello, server hello. Same thing just happened here. Just as using this, we can actually see the three-way handshake that has been established using the SYN, CNAC, and the ACK to show how TCP works on Wireshark. As end of the presentation.